Hello everyone, welcome back. In our previous lecture, we have covered how to calculate internal rate of return in Excel, and we have also learned that internal rate of return, that is IRR, has many limitations, and this is why often many analysts use modified internal rate. So overall, modified internal rate of return is a better version to find out return of the project. Here, by the term modified internal rate of return means the discount rate that causes the present value of project's terminal value equal to the present value of project's cost. Here, the terminal value or TV is found by compounding inflows at cost of capital. So this is the formula of modified internal rate of return. For this, we have to find out the terminal value of the cash flows. So the terminal value is known as TV, and this is the present value of the project cost. This is often the initial investment of the cost, and that's MIRR, modified internal rate of return, 1 plus MIRR to the power n. N indicates number of period. MIRR assumes that project's cash flows will be reinvested at cost of capital, whereas IRR assumes that project's cash flows will be reinvested at IRR, and for this reason MIRR method is better than IRR. Here is a solved problem of MIRR. There are two projects and weighted average cost of capital, or simply the cost of capital for both projects, is 10%. Let's look at project S. It has an initial investment of $1,000. Cost of capital or R is 10%. It will generate $500 in year 1, $400 in year 2, $300 in year 3, and $100 in year 4. All the cash inflows and initial investments are in million. So future value of this 500, which will be generated in year 1, is $665.50 at 10% compounding rate. So future value of 500 is $665.50. So this was calculated by 500 into 1 plus 0.1 to the power 3, because there are 3 more years after for these cash flow. After this, there will be 3 more years left for this project. So this is how it is calculated. This $500 will be generated in year 1. So 1, 2, 3. After this period, there will be 3 more periods. So this is how future value is calculated. 500 into 1 plus cost of capital, which is 10%. So 500 into 1 plus 0.1 to the power 3. Similarly, future value of second year cash flow, which is 400, is 484.00. So 400 into 1.10 to the power 2. Similarly, future value of $300 is 330, and the final cash flow, which will be generated in year 4, is $100, and its future value is exactly 100. So the sum of all this future value is 1579.50. This is the terminal value. So terminal value is known as the sum of all future values. So terminal value of this project is 1579.50, and initial investment is $1,000. So cost of present value of the cost of this project is $1,000. So based on this formula, so present value of cost divided by terminal value, present value of cost is equal to terminal value divided by 1 plus MIRR to the power n. MIRR of this project is 12.11%. So the acceptance criteria of MIRR is exactly same as the acceptance criteria of IRR. If MIRR is more than the cost of capital, the project will be accepted, and if MIRR is less than the cost of capital, the project will be rejected. So this project, that is the project S, is accepted because MIRR of this project is more than 10%, which is the project's cost of capital. The same way, we can also find out the MIRR of project L, and then we can compare project S and project L. So that's the formula of MIRR. Now let's look at what are the advantages of MIRR over the regular IRR. So first of all, IRR assumes that the cash flows from each project are reinvested at IRR, whereas MIRR assumes that cash flows are reinvested at cost of capital. And since reinvested at the IRR is generally not correct, and MIRR is generally better indicator of project's true profitability, or in other words, it is harder to achieve a rate of return of IRR, reinvestment rate of return at IRR. It is much easier to achieve a reinvestment rate at cost of capital, and this is why MIRR is a better method of measuring the profitability of the project than IRR. Secondly, MIRR eliminates the problem of multiple IRRs. So there can never be more than one MIRR. So we will often find that there are more than one IRR for a project, but if you use MIRR, there will not be any problem of multiple MIRR. There will be only one MIRR. So for this reason as well, MIRR is better than IRR to compute the profitability of the project. Now let's look at how IRR is different from cost of capital. The students often find it difficult to understand the difference between projects IRR and cost of capital. So for your simplicity, or in a simple words, IRR is just a measurement of profitability, whereas opportunity cost of capital is the rate of return that investors could earn by investing in other projects with similar risk characteristics. So, in conclusion, IRR is simply a measurement of profitability, whereas opportunity cost of capital is the rate of return that investors could earn by investing in other projects with similar risk characteristics. So the opportunity of cost of capital can be higher or lower or the same as IRR depending on relative attractiveness of alternative projects. That's all about this lecture. In our next lecture, we'll learn how to calculate MIRR in Excel. Then we'll also cover profitability index.